All right, so I'll let you know when the school gets toner again, but until then, I can't print anything for you, so you'll have to take notes the old-fashioned way. So if you didn't already, take out a piece of paper, title it Unit 5, Lesson 7, Abigail. Unit 5, Lesson 7. It's called Using Negative Exponents. If you need the title, because I am going to switch the screen, it's also on the board right here. Today's Wednesday, so look at the board. But yeah, Unit 5, Lesson 7, keep it with the rest of your notes for the unit. It's still going to be part of the binder check. And honestly, this is great practice for whenever you're absent, you really should be taking notes on your own paper, making up the lesson. And also just in college too, like some people think that like we don't need to take notes. And I'm just like, that's crazy. Like in college, you have to take notes. Like note taking is a skill. So, you know, what I say to that is the sooner you learn how to take good notes, the better. Doesn't mean you need to write down every single thing you see, just what's important that you can reference to later. All right, so Lesson 7, we're looking more closely at exponential graphs and equations. Stop. So you'll know that you're successful if you can describe the meaning of a negative exponent in equation that represent exponential decay, and if you can write and graph an equation that represents exponential decay to solve problems. Brendan, you know about this? You restart your computer that you use this print. There's a capital J. All right. So I am recording. Like always, it's linked in the slides, like always, so make sure you check that out if you're ever absent. Your practice will be the Lesson 7 puzzle piece, probably for homework, so make sure that you do that. So that's the best way to prepare for your quiz. The quiz was supposed to be today, but of course, the lesson took practically all hour, and you need about 30 minutes for the quiz. So that will change to tomorrow for sure, over lessons 3 through 7. So make sure your practice is done. Make sure that if you have questions that you either email me or ask me in class, because understanding the practice is the best way to prepare for your quizzes. And right now, with there not being a lot of stuff in the grade book, the quizzes are making a big difference right now. Until we take a unit test, like it's gonna fluctuate your grade a lot. And especially for you athletes, you need to be aware of the grade checks. Like there's a grade check every other week, including this week on Thursday. Now that doesn't mean like that your teachers will hurry up and grade your late work. If you don't want missings to go in the grade book, then like don't turn things in late. So FYI. I grade things within 7 days, sometimes sooner, but like the sooner you get it turned in, the sooner I grade it. So just think of it that way. Questions on that? Okay, so then here's your warm-up. So if I were you, I would write down warm-up. And it's not a math talk, even though it looks like it could be. You are rewriting each of the following as an equivalent expression with a single exponent. So solve each one of those on your paper. And we will go over them, I'd say, in about a minute. I don't think they take very long. So 1 minute. All right, so I'm looking for hand raises for the answer to the first bullet point. Landon. Okay, 2 to the 4th. Anyone get something different? All right, for that one, there's probably 2 rules you could have used. Landon, what did you use? Good. Do we remember in class what that rule is called when you add the exponent? Because they're being multiplied together? No? So that is called the product rule. So maybe write that down. Knowing the names of each rule might not be that important right now, but it definitely will be in the next. So sooner you get it down, the better. But that rule says that if I have the same base be multiplied, so the base would be like the x, you add the exponent. So yeah, you could have just done, since the base is 2 for both, 4 plus 0, which is 4, keep the base the same. What's another way you could have thought about it? 7. 2 to the 4th plus 0. No. Well, I guess I know what you're saying. You're saying that. All right, but there's one more way you could have solved it. Using a different exponent rule. Are we paying attention? We're just like. What's the rule for when something is to the 0 power? It's like timesing by 1. So really, you could have also thought of it as 3 to the 4th times 1, which of course anything times 1 is just that other number. So yeah, good. So now that you guys know the rule for how to solve these, I should see a lot more hands up when we do. So the second bullet point, what would the answer be? Henry. Brian? 2 to the 3rd power. Anyone get something different? Landon? Okay, so breaking it into parts, showing the rule, that still gives us 3, so yes. Any other answers? All right, that's right. So then the 3rd bullet point, Abby Guzman. What's the 3rd bullet point? Good, why? Good, so we're adding the -3, so yeah, that does give us a 1. Sorry, just making sure we're paying attention. Your head's down, if I think you're not paying attention, I'm more likely to call on you, but that's good, at least we know what's going on. Last one, volunteer for the last one. Luke? So use what they got in the previous ones to help you. Here's the rule. If we're timesing by the same date, so we add the exponent. So my answer would be, I mean, don't let them do it. Did the base change in the previous ones?
Sure.
This changed?
Yeah, for sure.
So 2 becoming 2 is a change?
Yeah. Not.
Okay, so then leave the base the same. Then add the exponents. 4 plus -4 is, so that is it. You could also simplify it to 1, but the problem was asking to rewrite it with a single exponent. So yeah, that would be with the exponent. Simplified would be what as the answer, class? No. It would be 1 if we simplified it, but it just wanted you to rewrite it with a single exponent, so that would be the answer. All right, questions on the warm-up? All right, so then moving on to the activity. Now there's a lot of words here. You don't need to write every single word down. Just again, the important parts. So we have a marine biologist estimates that a structure of coral has a volume of 1,200 cubic centimeters, and that its volume doubles each year. First, you're gonna use what we learned the past few days. You're gonna make an equation in the form y equals a times b to the t power. So that's our exponential function, at least one of the ways you can represent it. T is time in years since the coral was measured. Y is volume of the coral in cubic centimeters. You guys need to figure out what A and B are in this situation. So the value for them and what it represents. So discuss that briefly in your group, what A and B are and like the specific values for them. So table 8, just tell me what the A represents in the equation. So just what it represents. You don't have to tell me the exact value right now. Think about what we did yesterday, maybe last week. All right, class, help out. Initial amount, okay? So then knowing that A is your initial amount, then table 8, what is my initial amount in this problem? Good. All right, so when I make my equation, it'll be y equals 1200 times b. Table 1, what does b represent? Or like think about what we did in the other problem. In like previous problems, we also had an initial amount that we were timing by something each time. What's that thing called that we time each time? Or can you tell me what the b value would be? Okay, so maybe let me put it this way. If we're starting with 1200 and it doubles each year, what would I have at year 1? 1200 is what I have at year 0. So at year 1, I would have. So what am I timing by to get that 2400? 2, good. Katie did say it, so I'll give you that one. So then what's that word we defined yesterday, table 2, that we times by each time to get the next number? That's what we did yesterday. That word I had you, yes. So B is your common ratio. So that's what I'm timing by each time to get the next number. And it's 2 because it's doubling. So timing by 2, good. So then it's 1200 times 2 to the t power is my equation. So all you really have to figure out in each problem is what's my starting amount and what am I timing by each time. So there you go. Now in your groups, you're gonna find the volume of the coral when t is 5, 1, 0, -1, and -2. So I suggest making an input-output table to organize your answers. T would be my X or my Y. Good, your X, because X is your input, it's what's independent, time is independent. So in the X or the T, whatever you want to call it. You're gonna plug in 5, 1, 0, -1, and -2 into that equation we just came up with together. All right, to do that, use a calculator, especially on those negative exponents. I don't think anyone can do them in their head, not even me. And then if you finish that early, look at 3 and 4 because we'll be moving on to that rotating between 2 and 3. All right, so start with that. I'll give you about 2 minutes. So same reporter for the moment. It will change. So, stay on your toes. Make sure that we're paying attention. So table 3, no talking, just table 3. What is the y when x is 5? All right, let's see if that's right. All right, yes, it is. So if you're getting something other than that on your calculator, you're probably typing something in wrong. If that's the case, let me know. There's nothing worse than getting the wrong answer because you don't know how to use the calculator. And that's happened to me before too. All right, so that's what it should look like. Table 4, what is the y when x is 1? All right, good. Table 5, what is the y when x is 0? Good, and that one you may not need a calculator, but I say do it just in case because sometimes there's like a -4 somewhere in there in the problem, so just do it. It'll always tell you the right answer as long as you put it in the correct way. Table 6. What's the y when x is -1? Is it -600? Positive. All right. I don't think we can have a negative volume, so that's one indicator. But yeah, that's how you would put it in your calculator. Table 7. What is the y when x is -2? 300 is correct. Just to show you, this is what it looks like. If I can get to the button. 300. Questions? You'll be after you guys. There's a long line for the restroom, so try to not have to go. All right. So that's our table of values. The y represents what in the problem, class? It does say it in there, I'm not making you pull it out of there. Good, so all these volumes do make sense. Now, what does the x represent? The time. Is it possible to have a negative time? But they did make us put that in as an input. So what could it mean if they say time is -2? Landon? Years before what? So 2 years before. Good. 2 years before they measured the 1,200 centimeters cubed. All right, that's what it means. So if you see a negative, I mean, obviously we can't have negative years, but it must be before whatever they were measuring that starting amount, before they measured that starting amount. So that does happen sometimes where they say T is years after 2000. So if they say T is -3, what year are they talking about? 1997. So that's obviously the problem. It is possible now to have these negative exponents. And that's what it would mean. All right. Number 4, in a certain year, the volume of the coral is 37.5 cubic centimeters. In your groups, figure out what year that is. If you already know, great. Just in your groups, briefly try and figure that out. I'll give you about a minute. think they know, what year the volume would be, Peyton? Okay, so they're saying T -5. Anyone get something else? Okay, whoever was after Julian, I'll let that person go now, just to keep the rest of your line moving. Anyway, so let's see. T being -5, does it give us the volume they say? All right, yes, it does. So that is correct. Peyton, how'd you figure it out? Okay, guess and check. That's not a bad method. As you can see on the table, when the x's get smaller, what happens to the number? They get smaller as well. So if my output that they're wanting to find is 37.5, it's probably even smaller than the -2. So you could guess and check to see, like, if it's somewhere close. And just to show you, so like when I plug in -3, I get that 150, -4, I get 75. So we're getting closer. And then -5 gives me the answer they want. Did anyone find it differently? All right. Let's see what the book says. Because there are multiple ways. So another way that you could have done it is kept the pattern going. Of course, in the direction where the numbers are smaller. So as the numbers get smaller, what's the pattern, like going from 1200 to 600 and then 600 to 300? What's that pattern? So in other words, opposite of doubling would be dividing by 2, or multiplying by 2, or not by 2, multiplying by 1/2. So I could have kept the pattern going, like 300 divided by 2 is 150. 150 divided by 2 is 75, and then that's something you could have done. Here's the math way, because my first instinct would be, okay, well, they're giving us the volume, which goes in the y position. This was the equation we had. And t is the only unknown, so I should be able to solve it, right? In algebra 1-2, we don't really teach you how to get rid of that base. I do know how, and I'll just show you quickly, because it's like something we'll see later, but it's not something you need to know yet. So like when in doubt, you could find the pattern and keep the pattern going, or guess and check, which did work in this case. But otherwise, like whenever you isolate a variable, you start with what is, and in this one, it would be what? Good. So the 37.5 is already on the other side. We want to get rid of stuff that's on the same side as the t. And farthest would be the 1200. Opposite of multiplying 1200 would be whatever you do on one side. Good. And when I do that, I get a decimal. I'm not going to round it, because rounding could change my answer at the end. I'm just going to leave it as is. And then I run into that situation where it's hard to get rid of the base. When that happens, you could take what's called the natural log of both sides. So on your calculator, that's that LN button. And that's what removes the exponent. All right, so you do it like that. The right side ends up becoming t times the natural log of 2. This I would just leave as that. And then opposite of multiplying by the natural log of 2 would be dividing. Whatever you do on one side, do to the other side. And when I put this in my calculator, I do get -5. So that's a way that you probably don't know how to do, and we don't expect you to know how to do. But there is a way without having to guess, is what I'm trying to tell you. All right, but in your calculator, you have a natural log button. It's ln. This is what it would look like. And look, we do get -5. That's more like an algebra 3/4 thing, but in case you were wondering, that's how you find it. Questions on that? All right, so again, just make a table, keep the pattern going is probably the best strategy at this level. This one is a really quick one. Let's just talk about this briefly. Basically, someone put this in their calculator. So they're all correct graphs of the equation we made. So yeah, you can use Desmos to graph it for you. But depending on how big you make your screen could affect like how much detail you see on your graph, right? So like the more I zoom out, the bigger the numbers get, but maybe harder to see like the exact points. What's the difference between these three graphs? The y-axis is labeled differently. So can we see all our data points in graph A? No, and just to remind you, here were some of our data points. And then all the way from like X and Y being that to -2, I can't remember what that one was. Being 300. So it's like when we were labeling those blank coordinate planes, you don't want your scales to be too big and you don't want them to be too small. So what's wrong with A? It's too small. Good, the y-axis is too small. It goes to 2,000, but our data has up to 38,000. Probably not that one. What's wrong with graph B? Big. What number is that? 70. I think it's 1 million. Yep, 1 million. So again, too big. Our biggest number is almost 40,000. So the best graph to take would be this one. And it does have all our data points. So when it's too big, yeah, you can see more data points, but look at how small these numbers look. It almost looks like these are 0 when it's not. All right, it's like 40,000, but you can't really see that on this graph. Okay, good. Questions on that? You don't need to write that down. Just kind of little tip for you when you're using a graphing calculator. All right. Now here's a good question. You don't have to write the whole thing. Maybe just copy the table. A person took some medicine but does not remember how much. Concerned that she took too much, she has a blood test every hour for several hours. Time T is measured in hours since the blood test, and amount of medicine in her body measured in milligrams. What's the growth factor? Meaning what's the V? Okay, so it doesn't tell me anywhere in the problem that it's doubling, tripling, going down by 40%. It doesn't say that, right? But what does it give me? A table. And the time would be my input, output, or input. The medicine would be my output. So looking at just the output, what's the pattern? Don't say it out loud. Just look at it. All right. Table 7, what's the pattern in the table? So what's one way I can go from 100 to 50? Okay, I could subtract 50. Is that what is happening between the 50 and the 25? So then it's not the subtracting. What'd you say, Julian? Good. Now, for my equation, it's timesing, not dividing. So what's an equivalent way that I could say dividing by 2, but using like a multiplication sign? Multiplying by 1/2. Because B is for my, what was that vocab word? Common ratio. And remember yesterday, we learned how to find that. You take one of the terms, like for example 50, and divide it by its previous term, 100. What do we get? 1/2 or 0.5, same difference. That is what we're multiplying by each time to get the next number. So that is my B. Make sense? Question? That's how you can find the pattern if it's not that clear. See if it's adding or subtracting, and this one it's not. See what the common ratio is. So B is 1/2. What is A, table 8? A stands for initial amount. It doesn't tell me in the words, so you'll have to look at the table. What's my initial amount? Wait, what's my initial amount? Good. All right. Class, how do you know that's my initial amount, the 100? Good. Whenever the X or the T is 0, the Y is your starting amount. So good. So then my equation is, I'll write it up here. M equals 100 times 1/2 to the T times. All right, questions on that? So that's how you can find it when they don't explicitly say they started with this or they're happy each time. You can find it from the table by looking at the pattern. Now figure out the medicine when T is -1 and -3. The equation right here. So find the amounts of medicine when T is -1 and -3. Right, really the skill I'm testing you on is can you make the equation, which I think you guys are getting better at. And then can you use a calculator? Because I don't want you doing these in your head. All right, for time purposes, I'll take a volunteer. Who has it for when T is -3? Brian? Yes. All right, let's see. Hang on. Okay. All right, good. And that's what it should look like in your calculator. If you're getting something different, you're probably typing it in wrong. Like earlier, someone put a minus right here. Yeah, that's going to change your answer. It has to be times right there. So just small little mistakes you can make. What about when the T is -1? 200. you're getting something different and you're not sure why, let me know. So then now just interpret it. That's the goal for today. So knowing how to make the equation, I think we've got that. And then interpreting the meaning. So when t is 0, what does that mean? Right, talk briefly at your tables what it would mean when t is 0 and when t is -3 in context of this situation. What does it mean when t is 0? What happened at 0 hours? That's when she took her blood, is that what you said? Very good. When she first took her blood for a blood test, that's when she measured the initial amount of 100 milligrams of vein. Table 2, what does it mean when t is -3? Is it the 3rd time she took her blood test? Say it louder. So this is 3 hours before her first blood test. All right, so let's read it again. A person took some medicine but does not remember how much. Concerned she took too much. She has a blood test every hour for several hours. And when she first measured her blood, it was 100 milligrams, or I don't know what it is, milligrams or something else, remaining in her blood. -3 hours would be 3 hours before she started measuring. So that's how much she had before she finally started measuring. All right, questions on that? Good. So let me take you back to the goal. If you can make the equation, then you've met the goal. We've kind of been working on that for a few days. So if you're still having trouble, you need to speak up. Then describing the meaning of negative exponents. So negative exponents would be before the starting amount, sometime before that. Whether it's days, weeks, hours, we'll say in the problem. Questions? So then you have a decent amount of time to work on your puzzle piece and all the other puzzle pieces from lesson 3 to lesson 7. If you have questions, speak up because you're taking a quiz on those lessons tomorrow and they look similar to your practice.